For access control in Cadence. So this is week 2. If you've made it to week 2, I'm so proud of you. You made it all the way through week 1, where you went through Cadence and Flow CLI and awesome stuff with Morgan, who did a fantastic job. Thank you, Morgan, for that. And this week, we're going to start off by wrapping up Cadence by going over access control. So you might be wondering, Jacob, what is access control? And my answer to that is this kind of stuff right here, where you'll see public, the public set, access all, access contract. And I bet you probably haven't seen this before. And last week you were using pub a lot. So what I want to show you is the benefits and downsides of each of these access modifiers, we call them. And I'm going to be doing that largely through both this playground example and this diagram that I have here. So for this video, you don't have to, on the side, boot up a Flow playground on your own. You don't have to do all this. I'm going to link this playground inside the GitHub so that you can have access to all this code, and I'm going to add a bunch of comments everywhere so that you can go through that if you don't want to watch this video, or you hate me, or you find me annoying. No, I'm just kidding. So let's start off by going over this public set modifier. So what I've done really quick, what I've done is just set up a simple contract called sample contract. And in this contract, we just have one variable that's called test struct. And I just initialize it to an empty sample struct. So this sample struct is defined here. It just has 4 fields right here called A, B, C, and D, each with a different access modifier. And we have 3 functions. One that's access all, one that's access contract, and one that's access self. And you can see that I have initialized each of the fields to just easy strings. So now that we have this out of the way, let's go to our first variable here. So public set, what does this mean? Well, if we pull up our diagram, we can see that public set, which is the access modifier, has a read scope and write scope of all. So at first glance, this might be a little scary, right? Why would we ever want something to have a write scope of all? It's pretty dangerous. And if you were to think that, you're right. Because let's actually go to our script and let's try and modify that A field. So let's do .teststruct.a equals 17. So what I'm doing here is I'm accessing the test struct field, which is in the contract here, and I'm accessing .a, which is this, which has public set, and I'm setting it to 17. Now you'll see that there's no errors here, and this is a problem, right? Because any hacker could come into this contract, and if they wanted to, just modify A. Now sometimes you want this to be the case, and we'll see a lot during week 3 that public set can actually be very useful. But you should be careful when using public set because of the fact that someone can come in and change this outside of the contract, which is a little scary. And you know, if we can write to A, then it also is pretty obvious that we should be able to read from it as well. So we'll try that, .teststruct.a, and so you can see that we can also read from A. So this is just a very simple example of what public set is. Now, if we go to our next one, this is access all. And so this is probably what you have seen the most so far. Now I want to make it clear that access all equals the pub keyword. So if I was to actually change this to pub, that would be the exact same thing. I'm just going to keep it access all so that it looks pretty consistent throughout this. But let's try and learn what access all means. So if we go to our diagram here, it says that public access all has a read scope of all, but a write scope of current and inner. So this is a little different. So let's go to our script and let's try and read from variable B, or let's try and read from sample contract.teststruct.b. So you can see that we're reading from B and there's no errors here, right? But if we try and write to B, sample contract.teststruct.b equals 17, you'll realize there's an error here. And the error is it says cannot assign to B field has public access, consider making it publicly settable with pub set. Now you notice this is exactly what we did for A. A has an access modifier of public set, but B doesn't. B has an access modifier of pub. And you'll see that this gives us an error because the read scope is all, which is why we don't get an error for reading here on this line, but the write scope is current and inner. So we actually can't write to it outside of where it's defined. Now, you might be asking, okay, well, then where can I change it? And that is in here. So let's say we had a function called public function change b, and in this function, I wanted to do self.b equals 17. This works, and this is because of the fact that this is within the current and inner scope of where b is defined. Okay, cool. So I'll go back and delete this. And let's go on to C, which has access contract. So access contract, and by the way, I forgot to mention that we're only looking at the var because let is a constant, so the write scope doesn't matter anyway, so it's more interesting to look at var. So let's look at access contract now. And what this does is this has the write scope of current and inner, which is the exact same, but the read scope, instead of being all, is current, inner, and containing contract. So what this means is that if we go to our script and we try and do let variable c equals sample contract dot test struct dot c, you'll notice that we actually can't even read from it. And I'll comment out this error just for the sake of clarity. But you'll see that we can't even read from it. And the reason is because if we go to our diagram, you'll see that read scope says access contract is current, inner, and containing contract. So you might be asking, well, Jacob, then what's the point of access contract? And the answer to that is we can read it anywhere in this contract. So let's actually go outside of the struct and go down here and do public function I'm awesome, of course, right? And let's try and log self.teststruct.c. And you'll notice we can do that. We can read anywhere out of the struct. Now, of course, it's not that special because, well, we could also log self.teststruct.b if we wanted to, which has pub. But this is cool because C is saying that, we can read anywhere in this contract, but unlike pub and public set, we can't read outside the contract in a script, for example. So this will give an error. Now, you might guess that obviously if we can't read, then there's no way we can write, and that would also be the case, right? We can't write to it as well. So I'll comment out both these errors as well. Okay, cool. So let's go to the last example, which is access self. So if we go to our diagram again, it says that access self has a read scope of current and inner, so not containing contract, but just current and inner, and a write scope of current and inner. So if we go back to our sample contract again, or actually let's go to our script and just test that we can't read from it out here. We shouldn't be able to because it's just the current and inner scope. .d, see we can't even read from it, and I'll just copy and paste for the sake of time. You'll see that we can't even write to it, which we shouldn't be able to anyway, and I'll comment both of these out as well. So if you go back to our contract, you might be asking, well, then what's the point of access self? And I'll answer that here. So let's have a public function called change d, and let's try and change d. So pause the video right now and try and determine that given what this says, current and inner write scope, should we be able to write in this function? So pause the video for just a second. Okay, so now that you're back, let's try and do it. And if you said that it would work, you're right, because we're changing it in the current and inner scope of where D is defined. And, obviously we could, read to it as well. But, if we try to go down here to I'm awesome, let's see if we can, log teststruct.d. And we can't, right? Because the read scope is not the containing contract. It's just the current and inner scope. So this kind of goes over variables, and I hope this makes sense. Now, if we look at this diagram, there's a whole other section over here called functions. Now, what is function? So we can also use these access modifiers for, functions as well. So let's start again with access all, which has an access scope of all. Now, as you may have guessed, this function called access all function can be called, well, wherever, as long as we have access to the struct, right? So let's go over access control with functions. So sample contract dot test struct. And if we have access to the struct, well, then we should be able to call this. So access all func. And you'll see that this doesn't give us any errors, right? So there's no errors here. And this is because the access modifier for this function is access all. And again, this is the same thing as pub, right? So let's go on to the next one, access contract. Well, as you may have guessed, the access scope is current, inner, and containing contract. So if you go to our script try and pause the video again and tell me, will we get an error when I change this to access contract func? Well, now unpause the video and you may have guessed that access contract func gives us an error, right? It has contract access only, so we can't call it in the script. But if we go to our contract, we can call it, for example, in here, self.teststruct.access contract func, and that totally works, right? So this is just an example of how you would call an access contract function, okay? So this is just callable within the contract itself. Of course, as long as we have access to the test struct. All right, so here's the last one, access self func. So this just says it has current and inner access scope. Okay, well, if we go back to here, then, obviously this won't work if we try and call it here. We'll just try it for testing purposes. But private, what did I call it? I called it access self func. So this won't work, right? Because it has private access. So we'll comment this out as well because it's an error. And if we go back to our contract, well, we can't even call it down here, right? Because this is outside the struct. This is outside the current and inner scope of where it's defined. So we'll also get an error here. Well, then you may be asking, well, Jacob, then, what's the point of this? And the answer is that, you'll be able to call it in other functions that are defined within its current and inner scope. So let's just, in a function, in change D, right? Just for example, let's call self.access self func. And this works, right? Because it's within the boundaries of where we want this to be called, given its access self. So this kind of concludes access control. I hope that made sense. If it didn't, then I'm going to be including a playground example with a bunch of comments on it. So hopefully that will make sense. And of course, if you have any questions at all, please feel free to ask me in the Burning Questions channel. I will always respond to you there. I promise you no question is stupid. I asked a billion questions when I started as well. So I love your questions. You guys are doing awesome, and I'm very proud of each and every one of you. Keep going, and let's have an awesome week. All right, I'll see you guys soon.